Hi everyone, this is lesson 3, and today we're talking about particle diagrams. So yesterday, or in the last video, we talked about the classification of matter, the different types of mixtures, and the difference between elements, mixtures, and compounds. And today we're going to look at this bullet and learn how to draw particle diagrams of them. So again, particle diagrams, what they are, and how to draw them is what the topic of today is. So yesterday last video, we ended with this graphic organizer, and we had said matter if it could not be separated physically, we called that a pure substance, and if it could be separated physically, we called that a mixture. And then went further to say if a pure substance could not be separated chemically, it was an element. But if it could be separated chemically, it was a compound. And if we look at a mixture, mixtures we were talking about composition. And so if the composition is the same or uniform throughout, we call that homogeneous. And if a composition is not uniform or different, we call that heterogeneous. Now, a particle diagram, as you know, the title might suggest, it's a diagram of particles. And so we can draw them to show atoms, elements, compounds, mixtures, and even different phases of matter. So solid, liquid, gases, all this other stuff. So a quick review on pure substances. Pure substances are fixed composition, meaning, water will always be H2O. You can't just add an H, take away an O, add some other things because you feel like it. Water will always be 2 H's and 1 O. And they will always have distinct properties. So no matter where you look at water, it will always be the same. It cannot be separated into simpler substances by physical means. So that means you can't just, put a water molecule through a filter and say, okay, keep the O's, hold the H's. It doesn't work that way. And again, the properties do not vary from one sample to another. So again, water in the cup that I'm drinking right now is the same as the water, will act and look and be the same as the water coming out of your faucet, or, doesn't matter where the water is coming from. Okay. Elements are made up of only one type of atom and cannot be broken down by physical or chemical means. This is the simplest kind of substance we can have. And again, some examples are oxygen, nitrogen, carbon, and literally the 100+ elements on the periodic table of elements. Okay, so let's dive a little bit deeper into elements, and we can further classify them even more. So first we can say an element is monoatomic. So mono means one, and atomic looks like the word atom. So what a monoatomic element is, it's an element that has, just one atom of it. So just about all the elements except that last column, the noble gases, need to bond with something. But these monoatomic elements, until they found their partner, they just kind of chill in nature by themselves. Okay? Now, things that are kind of chilling by themselves until they find their bonding partner, we call monoatomic elements. But then you have some examples of diatomic. And di means two. And again, atomic means we're talking about atoms. So some diatomic molecules, I like to say they're scared and they can't go anywhere without their identical twin. So if you're a twin and you know what I'm talking about, cool. But these diatomic elements are, until they find, their binding partner and to make like a different compound, they need to be with their twin. And so we call them diatomic. Okay, again, oxygen, so O2, N2, those are diatomic elements. So now we can, introduce the terms atom and molecules. Because when you think of chemistry, you've heard these words so many times, but what do they actually mean? Are they the same? Are they different? They are a little bit different. So atoms generally refer to individual pieces. So here, and you guys could be drawing as well, 6 different copper atoms. So atoms generally refer to one piece, where a molecule refers to 2 or more pieces connected. So if the 2 pieces that are connected are the same, that is a diatomic element. So here we have 2 ends connected. So because we have 2 of them, that's a molecule. And here we have a molecule of water, but it's a compound because you have 2 different elements connected. So if you have one thing by itself, it's an atom. If you have 2 or more atoms connected together, it is a molecule. If those 2 things are the same, it's a diatomic element. If those 2 or more things are different, it is a compound. Okay. So a quick review on compounds. Compounds form when 2 or more elements join together or bond chemically. Composition is identical in each sample. So here is a molecule of glucose. And again, the sugar in my house, the sugar in your house, the sugar in Starbucks always has the same structure. It doesn't matter where you get it from. And you can break down this glucose molecule, and that's part of what digestion is, but that only happens through different forms of chemical methods, so different chemical reactions. And the properties of a compound are totally different than the properties of the elements that form them. So what that means is that if you have NaCl, that is your standard table salt. You eat it, it's fine, tastes pretty good. If you add it to your water when you're making pasta, it's fine. It's there. But sodium metal, so Na by itself, if you put it in water, it explodes. So sodium is actually a silver metal that you can easily cut with a knife. And when we get to periodic table, we'll go through this in more detail. But if you put pure sodium in water, it explodes. Now chlorine, so Cl2, and chlorine is one of those elements that needs to be with its twin until it bonds, is a toxic gas. So if you inhale way too much chlorine gas, well, that's not okay. But when chlorine and sodium come together, and when we get to bonding, it's only the transfer of one electron from one thing to the other, just the movement of one tiny electron. It takes explosive metals and toxic gas and makes them into table salt. Doesn't explode, doesn't kill you immediately. So I think that's super cool. Okay, so here are some more examples of compounds you can draw in the appropriate section. You have water, carbon dioxide, and ammonia. Moving forward, we have, so if we're going to draw particle diagrams, I want to break this up into individual sections and then we'll go through some practice. So a monoatomic element, remember, mono means one, and atomic means we're talking about, an atom. So if you're asked to identify or to draw, you should be looking for or drawing one type of circle not connected to anything else. So here is, monoatomic element. They're all monoatomic elements, same element, not connected to anything whatsoever. A diatomic element, on the other hand, you should see 2 of the same exact elements connected together. So these are your, remember, di means 2. So these are your scared elements that need to go with their identical twin. So if you see the same color, they are a diatomic element. So you can say, DE for diatomic element. Okay. Now, if you have a compound, you have 2 or more different elements. So again, we're going to use colors to show different elements. So here we have a blue and a green one. So this is a compound. All of these are compounds. And whenever you have a question like this, it will be very smart of you to label all the different pieces that you see. Okay, so here is this question. Try it out. What is represented by this particle diagram? So here you should say a mixture of monoatomic elements. Okay, because again, if you label all the different pieces, Me, Me. Next one, try this. What is represented by this particle diagram? So you should say a mixture of, if we label this is a diatomic element, this one's a diatomic element, so it's a mixture of diatomic elements. Okay, moving forward, what is represented by this particle diagram? So again, it's a mixture of, well, here is a monoatomic element, here is a monoatomic element, here is a diatomic element, so we can say this is a mixture of both monoatomic elements and diatomic elements. This one right here, what is represented by this particle diagram? You should say it's a mixture of, again, label all of your different pieces. So we have 2 or more different colors, so this has to be a compound. Here is 2 or more different colors connected, so this is a compound. So we have a mixture of compounds. Okay. Last type of this type of question, what is represented by this particle diagram? So you should say it's a mixture of, again, label all of your different pieces, monoatomic element. This is a diatomic element. This is a diatomic element. This is a compound. This is a compound. This is also a compound. So we have a mixture of compounds and elements. Yay! Okay. So let's just jump into particle diagrams of phases. So remember, a solid has a definite shape and definite volume. So if you were to draw a particle diagram of a solid, you keep all the little circles tightly knit very close together. If you can even just picture what an ice cube looks like in a cup. For a liquid, remember, liquids have indefinite shape, but definite volume. So what you're drawing / looking for are, your particles on the bottom of a cup. So one of the reasons I didn't draw all the particles up on top like this is because one, that doesn't exist. Liquids don't float on the top of the cup, and they're always on the bottom. And lastly, gases have indefinite shape, indefinite volume. And so when you're drawing a particle diagram of a gas, you just draw all the particles literally everywhere. No organization whatsoever. Okay, so that is it for today. On the next episode of chemistry lesson videos, we will be covering physical changes and physical properties. That's it. Bye.